Thank you.
Okay, so here we go. The purpose of this seminar is to look at Omni and Elpas as an access control solution. So we all know Omni and Elpas for staff duress, for patient wandering, for infant protection, for nurse call, nurse presence. But we can certainly make the system much more price effective if we also offer additional use cases that they can achieve using the same infrastructure, right? So in access control, the fact is many of you who, David Buska, you've been with us, Louis, you've been with us for a while, Matt also. So you know that Visonic Technologies at the time, we had one of the most popular access control systems in Israel. And that's quite, I guess, an honor for a system to have that kind of market share in a country that's very security oriented. And so we have a lot of experience in access control. When I designed the ELC the way you see it today, it was actually a replacement. It was designed to be a replacement for the AXS 100 access control system. And yeah, but it never really got there, but we have all the pieces are in place. So if we want to, we can certainly, or if you want to, offer the Elpas Omni system as an access control solution. And what do we need for this use case, for the access control use case? First of all, obviously you need authentication, which means that you need a mechanism to identify a person. Then you need a rule. Once you've identified him, you need a mechanism of defining and implementing a rule base saying certain individuals at certain times of the day at certain doors are allowed access. Also rules such as door ajar, if the door is open for a period of time greater than a certain number of seconds, or if the door is forced when it's not, when no access was provided, then these kind of things we want to alarm on. All these things are rules for a typical access control system. Their rules get a little bit more sophisticated with anti-passback, etc. You need a fire override. You need a mechanism to get inputs from a third-party system in case there's an emergency and you have to unlock the doors. You need to give feedback to the user that's at the door. You give him an LED feedback, you give him a buzzer feedback, whether the access is granted or denied. You need feedback if there's a trouble with the system, some type of a buzzer. You want to be able to monitor the door position, so you need inputs to monitor not only the request to exit, but you need also door position. You need a software and user interface to enroll tags. You need a software to manage your network. You need history that records all the data so that you can audit it later, who entered, when. You want to perform attendance using the system so you can have time and attendance. And of course, it's a security system that requires higher availability. That means that all of the devices have to be supervised. The network, the backend software has to be redundant. We need high availability and eliminate any single points of failure of the system that you have. So beginning with authentication, with the Omni Elpas solution, you have three basic categories of authentication. The first, we'll start with the weekend, right? So here, I've got, you see the camera, right? Here I've got this reader, which is, in this case, it reads NFC cards. I bought it on AliExpress for about 20 bucks. It talks Wiegand 34. Goes through this cable into the Elpas Wiegand interface box, the WIF. That goes on to the RS-45, onto the ELC, right? So we've got reader, third party, talking Wiegand 30, Wiegand 34, Wiegand 26. And then we've got 6 wires actually, 2 for the Wiegand, 2 for the power from the WIF back to the reader. So you're powering the reader. That's a nice feature of the WIF, that it's giving power. And the WIF also has 2 outputs that can control, in this case, the buzzer and the LED on the reader. So we're able to provide a full access control, both card reader as well as feedback to the user using the WIF. All right, and you can choose proximity cards. You can choose biometric, and just as a quick demo, so if you look at the blue tag here, that's this little NFC label, right? Cost you $50 or whatever it is, and here is your NFC reader, and I put the tag on, and I get the button down on the button, and that triggers the alert that can open the door, or the rule on the controller that can open the door. Again, if you look at the blue tag, right, this one here, look at the button. As I present the card to the reader, I get the button down, right? So that's, and I heard the chime, which is the alert triggering in Omni that can then be used to set the door, right? Remember, we've got the local indicator to set different outputs based on location. So in this case, the location is the proximity card reader, right? And going back to here, I can do the same thing with biometric. I can do it with a PIN code, a keypad, and other mechanisms for getting IDs of users. Right? The next, let's go up here to the phone-based access. So now I want to use my phone as my access credential. Here's my phone. And if I turn this down, here you can see on my desk I've got 2 NFC labels. So these we would put up next to the door, right? And I take my phone running the Loan Protect application, and you see my phone on the screen here on the right side. And I present my phone to the label, and of course nothing happens. Couldn't read an NFC tag. Try again. I read the NFC tag, and I got the alarm. The location of the tag is, in this case, the blue tag is door. One second, the blue tag, no. This is David's phone. And black NFC location, that's the black NFC. If I can look at the same thing on my web client, right? And I go down here and I present my orange, and there's the picture went up to the orange. I move it to the black. Now remember, the app has to be, the phone cannot be locked for this to work. So for a user to get in, he's got to unlock his phone and then present it. If you present the card, the app is not running, and you present it to the card, the app will automatically load. Right? So the app is associated with the NFC tag. There is a process that we go through so that not any NFC, you have to write to the NFC card tag telling that it's an Elpas device, right? So again, we're at the black, we go to the orange, the location change, and we can set the output and associate this with an output in Omni. So again, the NFC is being used here as a reader, essentially. The NFC label. Before, the NFC label was a credential, and now it's being used as a reader. So that is using NFC. You can also do the same thing with a QR code, sending an SMS. The phone can send an SMS to an SMS server. We've done this in Norway, and then that goes back to Omni. We get the fact that there's a phone at that door based on the phone credential, and the ID of the door is embedded in the QR code. That goes back to Omni. Omni decides whether the individual is privileged or not and unlocks the door accordingly. We also, the Loan Protect application also supports BLE reads. So if you have a BLE beacon, then you can use those as well. However, it's very difficult to control the range of a BLE. That's be forewarned. It's a very popular technology, but it's a little hard to use unless you want to tighten up or increase the RSSI threshold to the point where it's got to get very close, in which case you might as well use NFC, which is much less expensive. But the BLEs, I've got a couple of units here. Now you notice that David's phone here now shows that it's in David's campus because it left the LF and it's now in the GPS location. And the GPS is showing the geofence the GPS coordinates falls within the geofence called David's campus. So that is now the location of my phone. I'm tracking my phone. If my phone moves to another geofence, I can alarm on that as well. Right? So that's just something about the using the phone as a credential in Omni for access control. Finally, we've got the using video. So let me bring back my mug here. And for the video, I'm going to demonstrate using two different technologies. We have integrated with the AnyVision video system. That's a company based in Israel, actually, and it's got a lot of track record and a lot of success with the defense industry here, as well as abroad. Honeywell partnered with them. They've got investment from Microsoft. So the AnyVision does back-end face recognition and body recognition, and it does it very well, very reliable. It does, however, it is performed in the back end versus the RealSense camera, which is this guy right here, right? And I have one here that's actually wired, and I'll show you the architecture in a moment. Performing face recognition. And in that case, it's not a back end that performs the recognition, but rather the camera itself. So what we have here is the camera is connected via USB cable to Raspberry Pi. Raspberry Pi is hosting that camera, gets via the API commands of the RealSense, of the Intel, and it sends it back to Omni. So I've got in this demo, two AnyVision cameras plus the Intel RealSense camera. Okay, so if I look at them here, I've got the RealSense here, the AnyVision Door 2, AnyVision Door 1. Hey, Tim. Let's let Tim join. Hello, Tim. I'm on my way. Okay, so let's just move forward. So I said we've got three face cameras. Basically, the one on the right here is what's right in front of me is the AnyVision. Is the RealSense camera. When I move to the next camera, the location has moved to the first AnyVision, and then to the final camera. Okay, now I'm coming back, and finally to the RealSense camera. So what we're getting is the performance is quite good. I get relocation about within 1 second of moving my face into the frame of the camera. The RealSense camera has a range of about 1.5 meters based on my own experience. They say 1 meter. I'm getting more like 1.5 meters. The others, the AnyVision, seem to claim that they're getting longer. I don't know. It's hard to measure. But suffice it to say, a 1.5 meter or so is what you're going to be getting from these face recognition cameras, whether it's standard cameras or whether. What I'm running here, by the way, is I've got on 2 tripods just cell phones that are running an RTSP application that act as CCTV cameras, security cameras. So I didn't need to buy security cameras. I just took phones and I put this app that serves the RTSP. That is the demo, and what I didn't show you is here. This is the server, the AnyVision server. Again, as I move into and then back to, so I'm getting pretty good performance here. I'm sorry for the annoying chime, but that's what I put in as the output for this alert rather than actually unlocking a door or setting a lamp, right? So back to, let me just see if this is anything from us. Tim is on his way. Hello, Tim, welcome. Okay, so that's the face recognition for frictionless. So we talked about WeGen access, phone access, and frictionless access. We started with the phones. The next is using the Elpas LF, which we're all familiar with. But the news here, okay, let's first talk about the Wiegand. The ELC, if used as a door controller, can now provide up to 10,000 card records. So that's pretty good, i.e. the decisions made by the ELC, and we can store on it up to 10,000 cards, which is a respectable access control system. Right? The Wiegand interface, as I said, it's got 2 outputs that can set the LEDs on the reader, and it provides the voltage and the Wiegand on the way back from the reader to the Wiegand interface. That goes on to the controller makes the decision, and also feeds back. I've got another slide on that as well. We've got the RTE, the request to exit, also coming into the controller, and we've got we're driving the lock with a relay, and we're getting the door position also by an input and alarming in the event that the door is open for a period of time greater than whatever, predefined value. Here, we're looking at the ALC exciter as a standard access control reader. So we can sell this to and integrate this with third-party access controls. So let's say you've got a Honeywell system, you've got a Linnell system, or some third-party system, and you've got the controller by the door already, but now you just want to send it a Wiegand, plug into one of their Wiegand ports for readers. So the ALC's got a Wiegand out, and that we've had for a while. But the news here is that with the TRC, you don't need an ELC. You don't need a controller to send that Wiegand. So now actually we're developing, and should be available within a couple of weeks, the ability to get the RF and then standalone. This ALC will get the message, make sure that this message is coming from is an LF message from the tag containing the LF field ID, and then send that message out the Wiegand port. In addition, the 2 inputs that are here, one is going to set the green LED, and one is going to set the buzzer. So essentially, just like I had this Chinese access control reader for procs, for in this case NFC, I have the same thing, the same functionality in the ALC as being a plane, and that's something that we can sell easily, and electricians can install them and wire them to the access controller without any programming or anything, right? Any questions thus far? Any comments? Anybody excited about what's going on here? If this is interesting?
Very, very excited.
Yes, David, my apologies for being late, and I'm only sort of jumping into the back end of this, but what I see has great potential for me. So I will probably think about this before I ask any questions, so I'm not made to be looked too foolish.
Okay. I'm going to go back. I've got another slide. You missed a little bit on the video. I've got another, I'll come back to it as well. Here you've got the same, thank you, Tim. Here you've got the same concept, but rather than a third-party controller, you've got the ELC. And in this case, we've got the ELC itself does all of the interfacing with the door. Did I say the ELC? The ALC. That's very confusing. I don't know why we decided to give those names. But this is the ALC. And so we've got the door position connected to the input on the ALC, the request to exit connected to the ALC, right? Of course, the LF and the tag communicate. You've got the output that if you bring a relay can drive the lock. And of course, the RS-45 that communicates with the controller. So the ALC with all of the inputs and outputs is enough to be next to the door, especially now with the TRC, so you don't need even RF coverage from the controller. This is a self-contained unit that can be used for access control of the door, right? All of the different rules, and you just write the rules on the controller. So this is, first we had the third-party controller, where the inputs and outputs are driven by the controller. The door position and lock is connected to the controller, not to the ALC. Here, you've got the ALC as a self-contained unit where the ELC, the Elpas controller, is being used to make the decisions. And of course, everything is fed back to Omni. And all this is available today. This is,
David,
yeah. Right.
David, just one question, just so that I get this in my mind straight. What we're absolutely trying to deliver here is a great deal of flexibility around utilizing either prox card reader, an ALC, a third-party security solution, or a standalone solution specifically driven by Omni Elpas. Is that what I'm getting here?
All correct. And plus, we've added the face recognition as well.
Yeah.
Right.
Yep. Okay.
Now, Louis was asking if I can have multiple ALCs on a single ELC, and the answer is, of course, yes. Right? You just write you write the rules on the ELC, each one setting a lock based on the LFID received. Right? So the answer is a firm yes. And this is basically a similar, also related to your question, Louis. So here, if I've got a WIF, which is interfaced with a card reader at each door, and I need relays, right? So at the moment, the WIF is driving the card reader's lens. It's not driving the door. If you don't need to drive the buzzer and the LED on the reader, then essentially you can use one of those outputs to drive the door, and then you don't need all of the outputs on the ELC and on an additional I/O bus device. But what's the capacity? How many doors can you drive with a single ELC? So we have a rule-based generator in Omni that is used to generate local control rules simply by defining doors. So you go into your ELC, and you go to the door configuration. You say, okay, this ELC is driving 4 doors. That will generate 4 doors in the access control. Each door I need to go in and define, okay, to define this door, I need to define the hardware of that door. Show me which is the reader for that door. And we could do this for Elpas LF, or we can do it with a prox card reader, whatever. What's the reader? What is the output for the maglock? What is the input for the RTE? What is the input for the door position? Whether they're wired normally open, normally closed, etc. Let me just read what Matt asked. Hi, David. The face recognition, how does it perform with a mask? Okay, ask me that question when I'm done with with this. So we've got all of the inputs and the outputs, the trouble output. If there are time zones associated with this door specifically, now I've defined my door. Okay, so I've got doors, up to 4 doors. Once I've defined that, then I go ahead and I define my access rules, my door access rules, or otherwise known as DARs, DARs. And where here I say, okay, during these time zones, these badge groups, right, to these doors have access. So I define a DAR, a DAR is a list of doors, a list of badge groups, and a list of time zones that define when those tags can enter those doors, right? That is a DAR. How many DARs can I support in a single controller? Well, that depends on how many doors I need to drive. So that goes back to our table here and saying, okay, let's have a single ELC, assuming that all the doors are being driven by the relays on the ELC. I can just provide a single ELC drives 2 doors with 21 DARs, no need for any additional relays, all self-contained in the ELC. So I have an ELC, 2 WIFs, or 2 ALCs. That's fine, and we can program everything up. And if we want to generate that rule base automatically using Omni, we can, or we can program the rules themselves however we want to customize it. Let's move on. If we want to drive 4 doors with an ELC, we can get full function, i.e. all of these door force, door jar rules, everything, all the rules in there, because remember, we're limited to 32 rules, plus an additional I/O unit for more relays, because here we have only 3 relays, and that won't be enough to drive 4 doors. It'll be enough to drive 2 doors, but not enough to drive 4 doors. So we're going to add another I/O unit. Now, if I want to stop some of the, or reduce some of the complexity of the rules, so I need fewer rules to in my rule base, So if I have, if I eliminate the no force, then I can have up to 5 doors. And if I eliminate the no ajar, meaning if the door is kept open for more than a certain period of time, then I can drive up to 12 doors with a single ELC, simply because I need some additional IOs. I need 3, so 12 plus 3 is 15. That's the maximum that the bus can support, right? But if you want to drive the doors via the WIFs, for example, or by that, then you can go up to the full 15 readers, 15 doors per ELC. All of this is if we're driving the door using local control, rather than the back end using Omni making the decisions. Okay, back again to the face recognition. So we're ready for beta on the AnyVision. So if anybody wants to beta the AnyVision, let me know. We did it primarily for patient wandering or wanderer management, so that if we detect a senior at the door, we need to trigger the alarm. If we detect a face that we don't recognize, that's okay. But if we detect a face that's covered and we cannot recognize it because of the covering, then we want to lock the door. So that's a suspicion that maybe a wanderer is covering his face. Because we see a body, we see a person, but we don't see, we're unable to read his face. So that the AnyVision, all that logic is performed in the back end, whereas the RealSense, that logic is performed on the camera, and our API is picking up those events. You asked about covering. According to the specifications that I've read about both systems, they can handle faces, means I can identify faces with masks. Obviously, when you enroll the faces, you should enroll, you have to photograph the face, and there's a whole process of that. You can photograph with and without the mask, and that way it'll pick it up, and they'll be able to identify the face even while wearing a mask. A COVID type mask. So of course the eyes are exposed. But the AnyVision has a licensing scheme, but the product manager that I spoke with at AnyVision said, okay, just let's talk to the customers and we'll work something out. The RealSense is basically a much simpler model. It's a fixed price per camera, and they're not expensive. So I can tell you that I bought these for about $100 a pop. So we can put those all over. You can put multiple cameras at a door just in case you want to cover different angles, etc. Currently, the Raspberry Pi that I've got here supports a single camera, but we're going to work eventually on supporting, because since it's USB, up to 4. And I'll go into a little bit more detail here as to what the phase out of, or the rollout roadmap for this technology will be. So right now we've got the camera. I'm talking right now for the RealSense, not the AnyVision. The AnyVision is ready for beta. Back end, Omni we have an extension in Omni that's talking to that. That's how it works. For the RealSense, we wrote a host application running on Raspberry Pi, communicating via USB with the camera. It communicates back to Omni via either Wi-Fi or Ethernet, and that's what you saw before. Because right now, the camera is actually running, and as a matter of fact, if you want to see the camera, you can see, let me take this guy. Here, you see the camera here, right? If you see the IR flashing, you see with the naked eye, you don't necessarily see that flashing. It's constantly scanning for his face. It's got 2 cameras. So it takes stereo vision. It's actually doing a scan, and it's got 2 sources of illumination. So that's it. The RealSense. So phase number 2 is going to be, we'll take the same code for the Raspberry Pi, put it on our basically EDP Pi. As you know, we have our touchscreen display panel that runs using Raspberry Pi with a card, an interface card that interfaces with the RS485, and it's got IOs and stuff on it, right? So now we combine the RS-485 logic that we already have on the Pi with the hosting of the camera, which we already have, put it together, and send the card reads or the face reads as card reads back to the controller. The controller can make decisions and send back a command to set an output on the Pi to open and lock the door, or use a different relay. You can use relays on the controller. And it'll feed back to Omni as well. So that's phase 2. Phase 3 is we eliminate the need for the old ELC, and the Pi becomes the actual controller. So yeah, you're looking a year down the line anyway on this one. So that's as far as roadmap goes with the video. Questions thus far? Anything? I have any? Did I answer your questions, Matt?
No, not yet.
Okay, the face recognition, how does it perform with a mask? Although we're hoping to move away from masks, but some hospitals may still adopt. Right. So the masks, according to the documentation, I haven't really tested it thoroughly yet. The RealSense has a function where you can be accommodating to masks, and it will identify the face without the mask. So too, the RealSense also seems to claim that they handle masks okay. I haven't really tested it personally, but that's their claim.
Excellent. Thank you. Thank you, David.
Okay, the server control and ELC control. So we were talking I wanted to reiterate this. You guys probably more familiar, but for the benefit of those that might be less familiar. So the decisions may be made on the ELC. So the reader, it gets a reader ID, an ID from the reader, and it checks it against its rule base and unlocks the door. That's ELC control. And of course, that decision is all fed back to Omni, where you're going to have dispatching of the alarms further, or recording to history, etc. We also have the means of unlocking the door via the software, right? So the reader sends the badge message or the card read, just sends it. It's just a gateway between the reader and Omni. Omni gets the card read, performs the alert logic, sets the output back and unlocks the door. That's Omni-based access. Now, you can mix and match the two. You can have the same site having both simultaneously, or you can have the ELC be backing up the server so that as long as the server is functioning, the ELC is kept offline. What's the advantage of each? Well, the advantage of the ELC is that it's fully distributed, no single point of failure, independent of the IP network. No, if the IP network goes down, access control continues to function. It's got its own backup power. It's got battery, the ability for battery backup. It sends the feedback to the server. So, and even if that connection is lost, then if you're storing those events to the history of the ELC, as soon as the connectivity is reestablished, the server will fetch any of the missing events that occurred from the controller and replay them on the server for the benefit of the history and the dispatching of those alerts if necessary. So that's the automatic synchronization following a restart of Omni, that it fetches the missing data from the ELC and replays it. What's the advantage of the server control? Well, there's certain logic that requires the server. For example, anti-passback. If someone enters in door A, and then that same card tries to enter in door B, and you have a site that wants to enforce anti-passback, i.e. you cannot enter in twice sequentially, then you need to do that using server logic. We can't do that on the controller because the controller just knows its own bus. We don't yet have the mechanism of synchronizing all the controllers as to who's in, who's out. Secondly, you've got the ability to match PIN card and some other form of authentication. A PIN code, so if someone enters in, let's say he needs to present a card and put a PIN card in, or face recognition and a PIN code. So there are a lot of keypads out there where you have a PIN code and you need a card, but that's a generic PIN code for everybody. Here, if you're using back-end software, you can use a different PIN code for each person plus a card for each person, and then using the escort logic in Omni, like we use for the infant, the mother baby, you can match a card, PIN code, and prox card, let's say, or face, or LF, or whatever. And only with the combination of the two do you allow access, which is a big deal in the industry of access control. That can be done when the server is up, but if the server should fail, then we fail over to the ELC control, and in that case, it would have only one credential would be required, or you have a generic PIN code for everybody, and then that could be done with the ELC. You don't have the one-to-one relationships on the ELC, in the ELC control. So we already said that the ELC synchronizes. A nice feature in Omni is that if you make changes to the population of some of those groups of badges, it will automatically synchronize them with the controllers. So let's say you define your rule base in your controller. I've got a group called R&D staff. Anybody member of that group has access to doors A, B, and C. If I then go ahead with, like, say, my web client and add another badge to that group, that'll automatically propagate to all of the controllers. So the controllers will have that change on board. And even if the server should crash subsequent to that, then you'll be able to use that tag and be validated by the controller. All right. Similarly, we talked about getting that the missed events if there's any disconnect. Typical rule base and anti-backpack. We discussed all that. The benefits of Omni in general as a management system. So we've got in Israel, Omni, at the time Iris, became quite a popular security management system in and of itself. After we kind of dropped the access control, that went away at the time when we dropped the XS 100 and we ceased to really push access control within the market here. But you have just about all the elements. We no longer have the interfaces with intrusion systems. So typically in a security management system, you're going to want to see on the same map, you're going to see your intrusion alarms, your access alarms, and your CCTV. So we don't have all those pieces to be called a security management system, but suffice it to say that certainly for access control and for our other verticals, which would be staff duress or nurse call, etc., you could use the same interface for all of them, right? So some of the other benefits, site-wide anti-passback history reports, distributed control with the ALCs, high availability with redundancy. We have servers that are redundant. Multi-sites, you can have different buildings having different servers and them all synchronized using a master server. Cloud access, so you can have clients, web or mobile, that access the server through the cloud. And integrated with Active Directory, we're now doing single sign-on. And with Active Directory, building management system integration, nurse call integration, the ability to enroll tags at a web client with the necessary privileges, assign tags to groups that give them the access privileges. And of course, using the same infrastructure for staff duress, nurse call, infant security, wander management, and general real-time location and asset tracking. Which, I didn't put that here, so in case someone else from Centrac, because they kind of deem the asset tracking as their domain, but the security is us, so that's fine. All right, that's a wrap. Anybody Q&A? Anybody? Let's see. I've got a chat from Tim. David, can you go back to the CTV integration? Okay. CTV.
Just for my own benefit, David, we're seemingly getting a lot of requests for integration of CCTV cameras for the activation of events in the field. So let's say a duress alarm triggered either by a fixed duress or a mobile duress. Yeah. And the expectation that we will be able to integrate to CCTV cameras within the area of the duress event. What's the situation with Omni and CCTV integration currently?
Okay, so Omni, typically the CCTV integration that we have in most of the sites, and we have a lot of them, is where we use the API from the CCTV system to send them, to share with them the events in Omni. So you can assign a CCTV channel value to a reader in Omni. So when you have the alert at a particular reader, it will send a message to the CCTV system containing that channel, saying, okay, pop up camera number 5. Right? So again, we have the ability to display motion JPEG. So if you give me camera sources streaming motion JPEG, then we can associate that with a location. And then when you get an alert in Omni, it'll pop up that live video on the client, both the web and the EV2. But that hasn't really caught on. It's not, live video is limited in its benefit. But what really is needed is to send and share the Omni alarms to the CCTV system so that A, it pops up on the video wall or on the matrix, and they have it in their history so that they can replay a video stream clip of a certain event. So you got the location and the time of that event in that message. So that's the typical way. And each CCTV's got its own protocol, and usually we can find something without any need for development to push those messages to the CCTV system, if that's your question. You're on mute, Tim. Okay.
I'll try and unmute. Luis just mentioned that Avigilon is something that you've done some major integrations to. And it's also a very popular platform here in Australia. So that sort of gives me a lot of, in fact, within most of Queensland Health, Avigilon is the product of choice. So it does give me a lot of
we even
that we could
are able to define outputs in Omni that is used to trigger the camera or the display of the camera on the video wall. So, and those outputs can be placed on a map so that when you click on that, on the Omni map, it's going to appear on the video wall. In other words, that'll pop up the video for that camera. So that output is actually a camera, and through the Omni map, you can drive that camera, turn it on, or display it.
So the Avigilon interface, is it low contacts or is it a high level integration with some sort of an interface protocol from Omni?
It's through an interface. I know there were cases in Israel. I don't remember the details, but I remember being involved in a stadium that we integrated with Avigilon, and we were sending, and we used that feature on the maps, actually. That's what I was thinking of. And so we're sending it API packets to its system. It's not a dry contact.
Okay. Excellent. Thank you.
And as you see, Louis said, both hardwired and SDK.
Yeah, just answered the question for me. Thanks, Louis.
Yeah. Yeah, good one. Good one. Anything else? Anybody? So I hope I didn't lose anybody with the time change here or the link change, and somebody's going to answer to this back at Centrac. But all's well that ends well. Well, thank you very much, everybody.
Thank you so much, David, and stay safe, everybody.
Yeah, absolutely. Stay safe. Good one.
Thank you, David. Can you, if you get 5, can we catch up this evening sometime?
Sure. I'll call you in a couple of minutes.
Okay.
Thank you.
Thank you.
Thank you,
Thank you,
David.
David.
Bye, everyone.